Good day everyone, we are from section 13 group 4 and today we are going to present for the subject BIC 10103 discrete structure with the title of Minimum Path Linking Kuala Lumpur and Singapore by High Speed Rail. So here are the group members for our project. First we got Yubashni Vishwanathan, Yumni binti Abdulaziz, one Alia Najwa binti one Zain, one Muhammad Adam bin Kamarul Zaman, me myself Nyanasri Armugam, and lastly Nitishwaran Raghunathan. Next, I'm going to continue presenting the chapter 1, which is discussion of case study. The trigger for this project BIC 10103 discrete structure is the comparison of high-speed rail against other modes of transit from Kuala Lumpur to Singapore. The duty of producing a report on a bare minimum route between Kuala Lumpur and Singapore for a high-speed rail project falls within my purview as the head of department at Prasarana Centre of Excellence. Researching every terminal that connects Kuala Lumpur to Singapore and determining the separation between each terminals are the requirements for this project. So, the reason why this project is conducted is to determine all feasible routes connecting each terminal in order to determine the shortest route from Kuala Lumpur to Singapore. It is also to determine the length of minimal path we employed in Dijkstra algorithm as the mathematical model. The model was then translated into Java computer code.
Okay, so for my part, I'm gonna present about the starting point for comparing high-speed rail with alternative transportation options from Kuala Lumpur to Singapore. So as you can see in the map, the train is starting from the Jurong East train station, then going to Iskandar Putri station, after that Batu Pahar station, Muar station, Ayakaro station, Seremban station, Sepang Putrajaya station, then lastly Bandar Malaysia station. So these are the path for the train travel from station to station, another station. So for the red line, it is symbolizes the HSR alignment, and the black dotted line is symbolizes the KTM pad. Then the green dotted line is for north south expressway, and lastly the CIQ symbol is for the customs, immigration, and quarantine. It symbolizes that lah. So that's all from me now. Now I'm gonna pass to my another friend. Thank you.
Next is Chapter 2, is a discussion of suitable mathematical modeling. The Dijkstra algorithm was selected as the mathematical model for our research using the idea of discrete structure. Finding the shortest pathway between nodes in a graph, which may for example represent a network of roads, is the goal of Dijkstra method. Determining the shortest path by adding up the length of all the pathway after applying the Dijkstra method to get the shortest distance. The minimal path connecting Kuala Lumpur and Singapore is the one that corresponds to the distance calculated by using the Dijkstra method. And this is the route networks that we have proposed from KL Central to Jurong East, Singapore. The first point will be KL Central and the last point will be Jurong East. We have 11 points in total, and we also have 11 paths from KL Central to Jurong East. As you can see, we have KL Central, Gemas, Putrajaya, Sepang, Seremban, Air Keroh, Muar, Batu Pahat, JB Central, Iskandar Putri, and lastly will be Jurong East.
Okay, for Chapter 3, construction of mathematical model based on case study. Okay, the first path is KL Central to Putrajaya to Jurong East. The total distance for the first one is 312.8 km. For second path is KL Central to Sepang, to Seremban to Air Keroh to Muar to Batu Pahat to Iskandar Putri to Jurong East. The total distance for second pass is 326.9 km. For third pass is KL Central to Putrajaya to Iskandar Putri to Jurong East. The total distance for third pass is 312.1 km. For the fourth pass is KL Central to Putrajaya to Seremban to Air Keroh to Muar to Batu Pahat to Iskandar Putri to Jurong East. The total distance for fourth pass is 315.4 km. For fifth pass is KL Central to Putrajaya to Batu Pahat to Iskandar Putri to Jurong East. The total distance for fifth part is 313 km. For sixth path is KL Central to Putrajaya to Sepang to Seremban to Aikero to Muar to Batu Pahat to Iskandar Puteri to Jurong East. The total distance for six parts is 329.7 km. For the seventh pass is KL Central to Putrajaya to Muar to Batu Pahat to Iskandar Puteri to Jurong East. The total distance for seven pass is 316.4 km. For eight pass is KL Central to Gemas to JB Central to Jurong East. The total distance for eight pass is 312 km. For nine pass is KL Central to Putrajaya to Aikaro to Muar to Batu Pahat to Iskandar Puteri to Jurong East. The total distance for nine pass is 314.3 km. For 10 pass is KL Central to Putrajaya to JB Central to Jurong East. The total distance for 10 pass is 320.9 km. For the 11 pass, KL Central to Putrajaya to Gemas to JB Central to Jurong East. The total distance for 11 pass is 327 km. Okay, next we will present our coding.
To all of my friends, my name is Shubhashini Viswanathan and my matrix number is CI210086. So as for this project, and now for this part, I will be demoing the code that we used to apply the shortest path in our programming language. So in this project, we have used Java code, Java language, where we're still currently learning in our current semester. So to run this project, we used Eclipse as our programming software programming in order to run them. So now I'm going to explain the code, and I'm going to let know how the code and how the output will be displayed in our project. So as for this section, we can see that we've created a class named shortest path, and then we also declared a static final integer variable, and we initialized its value to 11, where we have identified 11 paths in our project. And then there is also we have created like for about 1 2 3 4 5 4 main methods to relate the code with the project. So as for the first method, we have named the data. It's at where it has a return value called double, and it named as mean distance method with two parameters. The first parameter data type is double with the name of distance and also an identified array size. And for the next one, it also has it is Boolean, and it also has an unidentified array size with the name of SPT set. So in this block, we can see that we have initialized two different variables with the double mean, and another one is mint index. So for this for looping, we used v as a variable name, and we compare this v value into this. As for this, here we also implemented if statement. If fpt set v equals to 4 and this v equals less than or equals to mean, where these two statements have to be true, then only that this statement will be executed in our code, that where it will return minimum index for this method. So next, here where we will print solution, but basically we didn't print the solution down there because it's not doesn't necessary for us to like print it out. So this is just as a reference for this, whether we wanted to confirm and clarify whether this code works or not. So for the third method, we will be going to the Dijkstra one, where we have a 2-parameter too. But for the first data type, it will be double, and the variable name is graph, where it has a 2D dimensional array, unidentified array size, and another one is integer src. So here we declare and initialize for double distance and boolean spt, where we will call using the where we use it using the variables from the first method, and we extracting it here. So as for the next part, we will see for the for loop, where we initialize I as our variable, where the height should be less than we using it this here again. And then we're also implementing the same code over here. If this thing is happening, then this thing will be keep coming up as these conditions are fulfilled. So for the next part, there's another loop too, where it counts spt set and minimum distance, where we will be using this over here too. So for the fourth class, we will be using distance with the 2-parameter sizes, with the total distance unidentified array size, and also string part with also an unidentified array size. So where here we declare int I is equals to 0 and total part is equals to 11. So for the and there is also we declare the double mean distance is equal to just as a reference for the code to read each and every distance. We declare the mean distance is equal to 313.0, and the string part is 0. And also we're not sure which part is the shortest path. So here we are using for loop, where the loop will happen, where it will like, how do you say that, it will compare each and every part that we have included in our code. It will compare each and everything, and it will see if the part 1, okay, for example, if we have part 1 0 and part 0, okay, here we use 0 part because that's the first ever part that will be used over here, so which is part 0. Okay, as for the array, every index size will be starting with 0. That's why we here use the string min part as 0. Okay, that's all. And then for this block, we we will be I would say we will be comparing each and every part one by one. So when we comparing each and everything, this if statement will be used, where if the total distance I, where this total distance I is less than mean distance, which is mean distance this. Okay, this is we using this as a reference, where it will compare each and one. So it's just as a reference for the code to compare each and everything. So that's why we use mean this just a random number from this parts, so it can easily compare and each and everything. So it will compare the total distance I with the mean distance. If it is less than, if total distance I is less than mean distance, it will take the path as a shortest path. So after it identify the shortest path through this block, then only it will go to this. So where the shortest path from KL center, it will be printed, it will print out over here, and for the shortest distance also it will be printed out over here with only one decimal place. So this is a main, where this graph is the part that we used in our these are the 11 part. As you can see, there is 11 part. 1 2 3 4 5 6 7 8 9 10 11. Okay, here are 11 part. So as for this 11 part, these are the part that we implemented in our project, and we declare it here as a reference. So Okay, yeah, that's for the path. And then here we have an object that we created that we will be using in this code, in this main string, where main string is where we will display each and everything, like every printing and display thing will happen here. So we created a object named G for this shortest path class, and G dot digextra and G, the object, will be accessing this method with this code that have been implemented, where we will be using this a variable, which this variable name and 0 as a reference. So first we will be initialize for us to, like, for us is starting, and double total distance will be start with 0 2, and the string path is also will be initialized as 0. So for the first thing, this one, it will be just a display where it will display linking path from, is just a title for the project. And then first part escape. As a project, first part is part 1 to from KL Putrajaya to JB Central. So the total distance is 24.4 plus 288. We implemented the calculation over here so that it will be easy for the system to calculate its distance, where it can easily calculate the total distance, so it can be easily comparable with the mean distance. So here we first using the first part over here that as we declared, which is 24.4 plus 280. So the total distance will be how do you say, the total distance will be displayed over here, and the path I equals to this. Okay, and then there, okay, we have followed everything. Every part is followed by a line over here, so these codes are all same, where it will calculate the shortest path and shortest distance. So here all the same. So as for this thing is, this line of code is where we will use the object G to access the distance method. So to access the distance method, where the double total distance will for this part, where is it, okay, this parameter is it represents the total distance of each and every part, and this part is represents this part. So we'll be calling that. So after we have calling that, after it has been calculated, the code will directly go to the distance method, and it will compare each and every part total distance with the mean distance that we have declared here. So after we have declared, then only it will see which one as the which one as the shortest path and shortest distance, and it will display the output over here. So as I explained there, madam can see here, this is what I meant earlier. Okay, this is what I meant earlier. Okay, as for the link, okay, the output, it will be the title that I said earlier is here, and then each and every part with the calculation, with the calculated total distance, will be displayed over here until the 11th part that we have in our project will be displayed over here. And then the project and the distance method that I've mentioned earlier, it will compare each and every path. And as for our project, the shortest path from KL Central to Jurong East is part 3, which is KL Central to Putrajaya to Iskandar Putri and Jurong East. And the shortest distance in kilometer from KL to Jurong East is 312.1 kilometer compared to the other distance that we have seen here. So this is the this is the shortest path and shortest distance for our project, as far as we conduct the research for linking path from Kuala Lumpur to Singapore. So that's all from me. That's all for our code part. And thank you for listening. And next will be presented by my other group member. Thank you, Madam.
As for the Chapter 5 analysis of the result, the extra give the ability to determine the shortest distance, the path that minimizes the overall distance in weight between the source node and all other nodes is determined by this approach using the edge weights. A report on the bare minimum route between Kuala Lumpur and Singapore for high-speed rail project is required of us as heads of department at Prasarana Centre of Excellence, PACE. Next, 11 routes might connect Jurong East and KL Central according to our research. The shortest route, which begins at KL Central and travels through Putrajaya, Iskandar Putri and Jurong East, is 312.1 kilometers between Kuala Lumpur and Singapore. Next, path 10 has the lowest distance of the other path, making it ideal for a high-speed rail project. This was accomplished using the Dijkstra algorithm. Each node in Dijkstra method is assumed to maintain track of its distance, and we have a record of the current nodes we have visited, which will be denoted as star, and the nodes that haven't been visited yet. All of the nodes in the table are give an unlimited starting distance, with the exception of the starting node, which has an initial distance of 0. All of these unvisited nodes are subsequently added to a queue. Since the process has just begun, the beginning node will always be the node with the current shortest distance, which is what the algorithm does next. This node is designated as visited, added to the list of nodes that have been visited, and added to the shortest path at a time. After being visited, a node is no longer included in the route. The method then examines the node's vertices to determine new distance values to assign to the node's neighboring nodes. The distance to a node equals to the current distance multiplied by the travel distance. A distance value can only ever drop, and if a greater distance value path is located, the node's distance value will not change. That's all from us. Thank you.